Okay, here's a couple of good questions. First one says to convert to degree measure. So I know that 2 pi is the same as 360 degrees, which is the same as 1 revolution, which is the same as 6.28 radians, and 2 pi, it's also radians. So if I want to convert this is a pi radian, so I'm going to use this one, and they want to convert to degree, which is this one. So I'm going to multiply this by a conversion ratio, where the one that I want to get rid of, the radians, goes on the bottom, 2 pi rads goes on the bottom, and 360 goes on the top. And degrees, that's what I'm looking for. So the radians, this would be radians, they cancel. And now, the pi's cancel. And then all I have to do is go 11 times 360 divided by 8. Whatever that comes out to on the calculator. I might as well do that on the calculator. Just a second. Okay, decimals. 11 times 360 divided by 8. 495. Next one. A bicycle rotates 53 times in 1 minute. Through how many degrees does a point on the tip of the wheel move in 13 seconds? So, that says how many degrees. So this would be 53 revolutions in 1 minute. And they want to know how many degrees it goes through in 13 seconds. Well, let's see how many revolutions it would be in 13 seconds. So it does 53 revolutions in 1 minute. Maybe let's convert that to seconds. So there's 1 minute in 60 seconds. So if I do that, that'll tell me how many revolutions it does in 60 seconds. But if I divide that, let me divide that, 53 divided by 60. So 0.88, and then a bunch of 3s, revolutions per second. Okay, and then they want in 13 seconds. So if I times this then by 13, I'll do that here, times 13. That gives me, I shouldn't have done that. Let me do it in a different step. So that's how many revs in 1 second. So if I do 0.883 and a bunch of 3s revolutions per second, if I times it by 13 seconds, that'll tell me how many revolutions it does. And that comes out to 11.48 and a bunch of 3s. That's how many revolutions. And then I need to convert that into degrees. So I have 11.48 and a bunch of 3s revolutions, and now I have to convert that to degrees. And I can use these ratios right up there. So I want to get rid of revs, so I put 1 rev on the bottom, and I want to get into the degrees, that's this one, so put a 360 there. So I just have to take that answer I had and times it by 360. So it comes out to 4134 degrees. Okay, next question. A bicyclist's average speed, linear speed, that's velocity, is that. The diameter is this. I have to get a radius, so I'll cut that in half. 35 centimeters is the radius. What was the angular speed? That's that W. In revolutions per hour. Now I have to be careful with that because the W, when I solve that, is in radians. So I'll have to convert that to revolutions. Okay, so let's do our formula. V equals RW. I want to solve for W. So I'll divide both sides by R. So W is equal to V over R. And the velocity is 53 kilometers in 1 hour. Okay, and then the radius is 35 centimeters. Now I have a problem here because I want to cancel those out, but they're not the same unit. But I do know there's 100,000 centimeters in a kilometer. So I can write that 100,000 centimeters, you see why I put that on top, so I could cancel these, is the same as 1 kilometer. And I can cancel those now. Okay, so let's type that in decimals. So I'm getting 53 times 100,000, and I have to divide that by 35. So I'm getting 151,428.57 radians per hour. Okay, so every time I use this formula to figure out angular velocity, the unit, and the radians just sort of appear out of nowhere, but the unit is radians per given time of hours. But the question wants revs per hour, so I have to do the same thing as I've done before here. I have to convert this one. So 151,428.57 radians per hour, and I have to convert that to revs per hour. So my units were 360 is the same as 2 pi, which is the same as 1 revolution. So I want revolutions, so 1 revolution is the same as 2 pi radians. Radians cancel, so I just have to take that answer I had and divide it by 2 pi. Okay, so I come up with 24,100.6 revolutions every hour. All right, question number 18. They asked me to find the phase shift. So phase shift is how far it goes to the left or to the right. And it depends on how this stuff in the brackets looks. This 2 is not factored out. So in order to know the phase shift, I'm going to have to use this formula. So the phase shift is whatever C is divided by whatever B is. The C is this one, so it's pi over 3, divided by, I'll write it like this, divided by whatever B is, and that's the 2. This is a complex fraction, and I have to fix that. So the way I do it is pi over 3, then this line here means divide, so I'm just going to write the divide sign beside. And then it'd be pi over 3, change the divide to a times, and flip this fraction over. Now I can multiply across. Pi times 1 is pi, 3 times 2 is 6. So my phase shift will be pi over 6, and you also have to, for the phase shift, have to tell me what direction. If this is positive, it means that the pi over 6 is shifted to the left. Always opposite to what you think. Okay, and the last question. A generator produces an alternating current. According to that, where T is time, what's the maximum current of this generator? Oh, maximum. So that would be like the generator is going to look like this. And so they'd want to know what that maximum point is. Probably the best thing to do with this one would be to graph it. Let's just graph it with decimals here. Okay, so instead of I, I'm going to use a Y equals 24 sine, and then I've got a bracket there already. 3 pi, instead of the T, I'll put an X there. Oh, that looks a little funky. Can't really read that much. Maybe I want to spread things out a little bit. So for my X's, maybe I'm going to go, say, from -1 to 1. Maybe I'll go up to 2. Well, that looks better. And then my Y's, I can't see all my Y's. There's a 24 in there. Maybe I'll put a low of -30, and a top one of +30. Yeah, there we go. Now I can see that graph a little bit better. Okay, so they say, what's the maximum? So I can just tap on that note there. So my maximum is at 24, right there. So max current is 24. And then they say at a time of 4.5 seconds. Oh, okay. So here's where I can go in. 4.5 seconds, I need to scroll over a bit. There's 4.5 seconds. And so right at the bottom there, that's where what the current would be at 4.5 seconds. But what I could do here is I can just type out x equals 4.5, and then I can see where that blue line crosses my red sine graph. So right down there at 4.5 seconds, the current is negative 24. So I could then say at a time of 4.5 seconds, the current is minus 24. All right, hopefully that helps you with those questions. Excuse me.